So our question is based on the motion of a rocket. But to understand this question well, let's draw the trajectory of the rocket, the path the rocket follows when it was being launched. We were told that the rocket started from rest. Say this is the ground. Then it moved with an acceleration of 3.2 meters per second. At the point, say A, before it got finished, and the altitude was 775 meters. So what happens is that when the fuel got finished, is that the rocket will slow down, then it will reach a peak, it will stop. Let's label this peak as point B. Then gravity will act on it, then it will fall down straight back to the earth. Let's label this point as C, as which is strike the ground. So we are going to use Newton's equation of motion and equation of a projectile, because this trajectory is that of a projectile, to answer our question. First, we have to find the velocity at point A, where the fuel got finished. We have to find the time it takes to reach point A. Then we will find the maximum height of the rocket, which is from the ground to point B. Then later, we will find the velocity at which it strikes ground, which is at point C. We'll also find the total time to move from the ground to point A to point B, then to point C. All this we are going to use Newton's equation of motion and equation of projectile. But first, let's find our first answer. The first question, question A, says that we should find the velocity at point A. To do that, we use Newton's third equation of motion, which is V squared is equals to U squared plus 2as. U is our initial velocity, the initial velocity of the rocket. But since the rocket started from rest, from the question you say the rocket started from rest, U will be 0, because it's not moving at the initial point. It was not moving before it was giving the acceleration. A is the acceleration of the rocket. S is the altitude, which is 775. So since U is equals to 0, initially at rest, then our V will be equals to square root of 2as. So V will be equals to 2 times 3.2 times S is 775. So if you use your calculator, you have 70.4 meters per second. Note that we have taken the upward direction of motion of the rocket as positive. So if the upward direction is positive, the downward direction will be negative. We will use this concept in finding the velocity at which it strikes the ground. Since if the rocket is striking the ground, it's moving in the downward direction, so the velocity will be negative. But going up is positive. That's our velocity here is what? Positive. That is aside. So we've gotten the velocity at point A, where the rocket got finished. So the next question, B, is to calculate the time it takes to reach that point. The point is point A. We still are going to use Newton's first equation of motion, which is V is equals to U plus AT. In the same vein, our U is equals to 0, because the object started from rest. So U is initial velocity. So we will have that our V is equals to AT. So making T is what we are interested in, time to reach point A. T will be equals to V all over A. This our A is acceleration of the rocket. This other A in the diagram is point A, is not acceleration. So please take note. So now T will be equals to 70.4 all over 3.2, which is equals to 22 seconds. So that is the time it takes to reach point A. So now let's do the third question, question C, is to calculate the maximum height of the rocket. The maximum height of the rocket is the height of A, which is 775, plus the height between A and B. Let's measure it as theta h. The maximum height is this height between B and the ground. So say to the ground h, let's label the maximum height as hm. So we need to find theta h. Hm, which is the maximum height, is equals to 775 meter plus delta h. But delta h from the projectile equation is equals to v square all over 2g, which is equal to 70.4 square all over 2 times 9.8. So delta h will be equals to, if you use your calculator, will be 252.86 meter. So since we got our delta h, now we solve, we get our hm. This is the maximum height the rocket reached, is 775 plus 252.86, which equals to 1027.86 meter. That is the maximum height of the rocket reached. I hope this is clear. Let's move to the next question. So the next question is question D, that we should calculate the time the rocket takes to reach the maximum height. The maximum height, as I said earlier, is point B. Take note of that diagram, is point B. The time to reach point B is equals to time to reach the point B, which is the maximum height, is equals to time to reach point A plus time taken by the rocket to move from point A to point B. We know the time to reach point A. We've calculated it earlier in question B. We got it as 22 seconds. TA is equals to 22 seconds. But we don't know TAB. TAB can be gotten from projectile equation, which is TAB equals to V all over G. So we call our V is 70.4 all over 9.8. So if you do use your calculator, you have 7.18 seconds. So that is the time to reach from point A to point B. So our time to reach point B, which is our maximum height, will be equals to 22 plus 7.18, which is equal to 29.18 seconds. I hope this is clear. That is the time the rocket takes to reach the maximum height, which is point B in our diagram. So the next question is to calculate, question E, is to calculate the velocity at which the rocket strikes the ground. The rocket was initially at rest at the maximum height B before gravity acted on it and it strikes the ground at point C. So we use Newton's third equation of motion, which is V square is equals to U square plus 2GHM. So we are considering HM because the object was at the maximum height before it strikes, and that was its initial position. And at that initial position, at the maximum height, U is equals to 0. So the velocity at which it strikes the ground Let's label that as Vg. Velocity at which it strikes the ground, Vg, is equals to square root of 2 GHM. G is the acceleration due to gravity, which is 9.8 meter per second squared. So 2 times 9.8, HM is 1027.86. So if you use your calculator, you have your velocity to be 141.96 meter per second. Note that velocity is a vector quantity, so it must have direction. I told you earlier that upward direction of the rocket, we took it as positive. So the downward direction at which it's moving before it strikes the air to be what? Negative. So here will be negative. So the velocity will be minus 1, minus 1, minus 1, for 1.96. So the negative sign is very important. So the last question, question F, we are asked to calculate the total time the object spent in the air before it reached the ground. Is the total time of flight. Let's label it as TF. That time is equals to the time the rocket takes to reach point A plus the time it takes to move from point A to point B plus the time it takes to move from point B to C. We know TA, we know TAB. TA is 22 seconds, TAB is 7.18 seconds. We calculated it earlier. But TBC we do not know. To get TBC, we use Newton's second equation of motion, which is S is equals to UT plus 1/2 GTBC squared. This is TBC. So, but U from the maximum height, U is equals to 0 at the maximum height. So we make TBC subject to a formula. So we have S to be equals to 1/2 GTBC. So TBC will be equals to 2S, this is square, sorry, 2S all over G square root. So this will be equals to S is the maximum height. S is the maximum height, so it will be 2 times 1027.86 all over 9.8. So TBC will be equals to, if you use your calculator, you have 14.48 seconds. 14.48 seconds. 14.48 seconds. I hope that is clear. So now to get TF will be equal to TA, which is 22, TAB 7.18, then TBC 14.48. So that will be equals to 43.66 seconds. So that's the time the object took in flying from point A down to point B and down to point C. That is the total time of flight. I hope this is clear. Thank you for listening.